Hello, and welcome to our little snippet add-on to our Chapter 8, Section 2, the Pythagorean Theorem and Triples. There was something at the very end of this lesson that I did forget to touch base on, and it involves triangles that are not right triangles and the Pythagorean Theorem. So, as we know, there are four types of triangles that are related to their angle measures. We have acute triangles, obtuse triangles, we have right triangles, and then we also have a fourth classification, which is equiangular. Equiangular. Now, in this context, equiangular just means all of the angles are 60 degrees, making it an acute triangle. So in this context, we're actually not going to even worry about equiangular. We are going to just focus in on these three. And the Pythagorean theorem is related to all three of these. For instance, if this is truly a right triangle, we know the Pythagorean theorem holds true. A squared plus b squared is equal to c squared. Okay, but what happens if I give you three sides, or what happens if a squared plus b squared does not equal c squared? What if one sum or one side of the equation is more or less than the c squared? Well, if the hypotenuse is larger, so let's say a squared plus b squared is larger, and notice that it's a less than symbol, but we're saying the hypotenuse is larger, then this is an obtuse triangle. And the inverse to this is if the hypotenuse is smaller or less than the sum of the other two squares, then it is an acute triangle. So for instance, if we take an acute example, and let's take that equiangular example. If all the angles in a triangle are 60, 60, 60, then all the sides are congruent to each other, 5, let's say 5, 5, and 5. So we would have, for instance, if we would order this, they're all the same size, so small, medium, large doesn't really qualify. But we could still say 5 squared plus 5 squared is what to 5 squared, okay? Actually, no, let's not do that. Let's do a simpler example to this. Let's do, what if the lengths of a triangle were 6, 8, and 9? Well, this is your small, this is your medium, this is your large. And by default, this would be your hypotenuse. If this was a right triangle, it would satisfy the Pythagorean theorem. 6 squared plus 8 squared is equal to 9 squared. But it should not work in this particular case, so we're going to actually see what it's actually equal to. Is it going to be less than, or is it going to be greater than? Well, 6 squared is 36, 8 squared is 64, 9 squared is 81, and what would be the placeholder? What would be the inequality between it? Well, 36 and 64 make 100. And what is 181 comparatively? 100 is greater than, meaning the hypotenuse is smaller than the sum of the two sides, meaning this is an acute triangle. Okay? Now, similarly, I'm going to use these not a similar triangle, but one that has similar numbers. I'm going to do 6, 8, and 12 this time around. It'd still be small, medium, large. And plugging this into our Pythagorean theorem, we know it's not going to be equal to in this particular case. And we'll see what happens. Well, once again, these are the same values, so that we could jump to the conclusion this is going to be 100. And then 12 squared is 144. 144 is, in fact, bigger than the sum of the two squares, the 100. So this makes this an obtuse triangle. Okay? So these are the only two add-ons that we have. We can now determine if you're given all three sides to a triangle, is it obtuse, acute, obtuse, or right, using Pythagorean theorem and its inequalities. All right. If you have any questions, please shoot me an email, and I'll get back. I'll see you in the next one. Bye.